All right, so calculus. Lots of people, they hear the word calculus and they start stressing and panicking that it's just this awful, awful topic, and they have no idea. And then maybe they hear people in the US talk about calc, pre-calc, and blah, blah, blah. And it shouldn't be that stressful, okay? The actual process itself is pretty straightforward. Some of the applications of it may be a little bit more complicated, but it's hit and miss as to whether you're going to get an application question or a straightforward one. When you get the mock papers back, you'll see that one of the questions crossed out was a pretty straightforward one. As I said, right, so calculus is the overall topic, okay? Within calculus, we have something called differentiation, and that's all you're really going to need to know about. There's something called integration, which is the opposite of this, but we're only going to look at differentiation. So when asked to find the gradient of a straight line, we can work out the rise over run, and this will give us an answer. Yes, you all happy with that? Straight line, find the rise over the run. Okay, so in this straight line here, I've got two options. I've chosen two different options. I've got the red one and the blue one. So the red one, I've got 1, 2, 3, 4 squared over 2. And the blue one, I've got 2 over 1. Either way, my gradient simplifies to be 2. Yes, so we just chose 2 points on the line and found the gradient by doing rise over run. Easy. With other graphs, hopefully, we can see that the gradient changes depending on which part of the graph we're looking at. So, as I say, back up to here, if I said I wanted to know the gradient of this graph, this line here at this point, it would be exactly the same at any of the points. Now, when I say at the point, I'm talking about a specific value of x. Okay, so that's what I'm talking about. Here, as I said, I'm hoping that you can appreciate that the gradient changes. So if I were to look at the gradient at this point on the graph, what we can do is we can draw a tangent to that line. Okay? Have we ever done this before? No? So you would draw a tangent. What's a tangent? So what does the line do to it? Does it go through it? Does it hit it? Just touches it, yes? So what we're doing is we would lay our ruler on here. Our ruler is going to be straight out. And we would draw a straight line just touching the point that we're interested in. Yes? And we can then measure the rise over the run and find the gradient that way. Okay, so we could do that. So you would just draw a line so it just touches that particular point. Okay? You can find the rise over the run. Now, for this particular point, okay, I can see that my line is quite steep. It's in which direction? Up, which means it's a what kind of gradient? Positive, and it's quite a high number because it's quite steep. Yes? You remember that? If I had chosen this point here, what can I say about my gradient at this point? Positive? Not quite as steep, yes? And what about this point here? Negative? High negative, yes? What about, let's get a bit more down there with colour. What about this point here? The blue one. Not undefined. It's a couple of people said it. Zero. So remember, horizontal lines means you've got a zero gradient. Okay, because there's no rise, there's lots of run. So it would be 0 over whatever. So this one would have a 0. What about this one here? There's my tangent. Pardon? Yeah, this one's also 0. Yes? So can we see how the gradient is changing? So we've got a high number, not so high, 0, going into the negatives. 0 going back up to positive. So our gradient of our graph is changing, which means that we can't simply choose any 2 points, find the rise over the run. Okay? You could, as I said, add a push, draw a tangent and measure it. I think I've got this written on the next page as well. You could add a push, draw a tangent, but is that going to give you a very accurate measure? I would suggest probably not, because Chiara's straight line could be quite different to Gabrielle's. When I say quite different, it's not necessarily going to have exactly the same rise over the run. Plus the fact you're going to have to work out your measurements, because your scale is going to be different each time. So that's not the most beneficial way of doing it. So in these cases, what we would do is we would actually use calculus. So the process of differentiating, we would differentiate our graph, our equation, to give an expression that tells us what's happening to the gradient. The difference is that here, for a straight line, we just get a number straight away. It's the same the whole time. Here, we're going to get an expression. Okay? So this expression is going to still have an x in it. And that's why it changes depending on the value of x. So the expression is called the derivative. So what we do is we differentiate and we end up with a derivative. Okay, so this derivative that tells us about the gradient. More specifically, it tells us about the gradient of the tangent. Get your determinant. So it tells us about the gradient of the tangent at each of these different points. Then, as I said, if we're then asked to find the gradient at a specific point, or at a specific value of x, we then substitute that value of x into the expression, and we can find the numerical value. Okay, so do we understand the concept of calculus or differentiation as we're looking at it? We're trying to find what the gradient is of a function at different points. Okay? So, finding the derivative will allow you to calculate the gradient at any given value for x. The rule for differentiating. Power goes in front and take 1 from power. Or multiply by power and okay, said slightly differently, same situation there. Power goes in front, and you take 1 from the power. So that's the process of differentiating.
Are you gonna are you gonna explain why any of this stuff? Why are we doing this stuff? Because that's too complicated.
To find gradients of stuff. So you're not always going to it's not always going to be a straight line. So you know lots of different. We're going to look at kinematics, which are rates of change in things. All relates to that. To be honest, a lot of these things get to the point where it depends on which career you go down whether you're ever going to use this. So, but we have to teach you basics.
Oh yeah, I know that. What do you mean like take 1 from the power? Is it like
literally if the power was a 5, it's going to become a 4.
Oh, okay.
Okay.
So then, but then if you multiply by the power and then take 1 on 1. Oh,
I'm showing you an example.
Oh, okay.
Okay, so that's the rule. So if y is equal to x cubed, if we were finding the derivative, or if we're differentiating it, they may say differentiate this. Okay, so they may use the actual word. They may say find dy dx. Okay, so if the formula is y equals, so which is mine is, then what the derivative would be shown by dy dx. Okay, so the derivative would be shown by dy dx. So it might say y equals x cubed, find dy dx. So you have to recognize that if it says find dy dx, it means you're differentiating it. Okay? If it says fx, okay, this is function form, we've talked about functions, we don't know about functions, then the derivative would be shown with f dash x. Now note that some people get confused when they see this dash, and they think that it's the -1, which tells us inverse function. So please make sure that you're recognizing the difference between a apostrophe or a dash rather than a -1. Okay, so both of these two things here represent a derivative.
Wait. Oh, so it's just okay.
Okay? So if your original question, my original question here says y equals. So to show I'm differentiating it, I would write dy dx equals. If my original question had said fx equals x cubed, I would show I was differentiating it by writing f dash s equals. Okay? It's just so you recognize that there are two different ways of showing a derivative. Both the process, however, is the same for both. Okay?
Wait, Sarah, what did you say? That you're differentiating it. That means finding the grade.
Finding an expression for the grade. Yes. Yeah.
Yeah.
These are all good questions. These are all important. You need to understand what we're actually doing and why we're doing it. Now, if there's a coefficient or value in front of x, then we just multiply the power by this number. So, here we go. Here's our first example. If y equals 3x to the power 5, then the derivative would be, so it's a y equals, so I'm going to write dy dx. Okay, so I'm showing the person marking it that I am differentiating it. Okay? Well, actually, I should have written something up here, but I had a gap there.
Oh yeah, I was going to say that, but I thought you were doing.
No, bless my heart, I just didn't read it properly.
Oh, what?
Can we take a step back to up to here?
I'm scared.
So, following our rule, the power goes in front. So my power is what number? So that goes into the front bit. Okay, so I would write 3x, and we would take 1 from the power. So taking 1 from that gives us 2. That's it. So that's the answer. The derivative is 3x squared.
Where do you get the 2 from?
You took 1 from here.
Oh, so then when you subtract from the power and that becomes a new.
Okay? Now, do we see why math teachers perhaps often say what they talk about why it's so stressful? That process itself is not too stressful, is it? Yes?
That's so easy.
Now, admittedly, there are some extension types things to it, but the process itself is straightforward. Yes? Good. Coming down here, as I said, if there's a number in front of it already, that stays there. Okay, so that doesn't get ignored, but it is now becoming part of our question. So our power comes in front, so we're going to have 5 comes in front. We've still got the 3, so I'm going to put a multiply sign just because I know I'm multiplying it. And I'm now having x to the power what? 4. Because 5 take away 1 is 4. Now, we wouldn't leave it like that. I'd actually work out what 5 multiplied by 3 was. Now, this is our working step. In your real thing, you can go straight to writing 15x to the 4. Okay? I'm not expecting you to write this step each time. We're doing this because there are notes. It's the first time we meet again. Yeah?
Why is it 4?
Because you will always reduce this number by 1. Okay. If there's more than one term to an expression, okay, so sometimes we have lots of things together. Yeah. So if we have multiple terms, we just differentiate them one by one. So y equals, so we know that we're differentiating because we've written dy dx equals. So our power comes in front and we take one off the power. So Emily, what would this one be?
It would be 4x3.
4x to the power 3, good.
Oh, finish it?
No, I'm just good. Right. Dinah, what would my next one be? Good, so what, can we do that in our head? Or do we want to do it separately? We can do that, okay, can't we? What's 3 multiplied by 2? Now, this sign, who does this sign belong to? The 2. So we're going to write minus 6x squared. Yeah, you all happy with that?
What's the point of writing the dy dx?
To show that you've differentiated it. Because if you just wrote equals, it's not equal to it. Okay? And then power comes in front, take one off the power. Do we write power 1?
No.
No. Okay? Now, when asked to differentiate a term with just an x, okay, you'll notice that the solution has no x and it's just a coefficient of it. Let's establish why that is. So, this can be written as 8, sugar popsicles. 8x to the power 1. Yes, you have that? Same thing. So the rules of differentiating would be that my power comes in front and we take one off the power. So this becomes 1 multiplied by 8x to the power 0. So that's dy dx. But what do we know about anything to the power 0? So this is actually going to be just 1 times 8, which is 8. Or multiple 1 if you want. So rather than go through this each time, if there is something with just an x next to it, your derivative will just be the number in front of it. So I can say straight away that the derivative of this is 3, the derivative of this is negative 5. Okay? Because if it just has an x, it
So we
will...
have to say dy dx equals.
Yes, you should do.
But then on the other one, should we do that?
Yeah.
Okay.
Okay? Now, when differentiating a constant term, so a constant term means it has no x attached to it. Which is the constant term in this expression here? 4, yes? So, what we're doing is we're differentiating with respect to an x. Okay, so we're anything with an x, that's what we're differentiating. That means that if there is no x attached to it, the derivative would be 0. Okay, so if you're differentiating a constant term and one that has no x attached to it, the derivative is 0. So if I were to differentiate this expression here, firstly it's written as fx, so to show we're differentiating it, we would write f dash x Oh, isn't it?
Yeah.
Oh,
It's okay, but because it has dy dx.
that's funny. So this would be what? Let me think of someone. Emma, what's the first term going to be?
For x, for dy.
Do I get
It'd be 15x.
15x squared? Nice. Then A, the next one?
It would be just negative.
Good. -2. And the plus 4? Just disappears, yes? If you wish to write plus 0, please go ahead. Otherwise, you can just leave it. Okay? I'm sorry, pardon? Yeah, yours says y equals, and it's written dy dx. Right?
So can we just cross out the y equals?
Sorry, pardon?
Can we just cross out the y equals?
You can leave it like that. Your notes are fine. I was trying to mix it up. I obviously printed the wrong version. When I printed it. Am I not making sense? Now, just so that you are aware, and I say this, and I'll probably see lots of listening, and then an exams or tests you won't do it. But my tip to you is that here I can see I've got an x cubed, I've got an x, and I've got a number. None of those can be joined together. Agreed?
Yeah.
So when I differentiate, I have terms, and they cannot be joined together. Okay, because the derivative of each of these types of things are different. Now, the reason I say that is because sometimes people forget and they see the plus 4 and they write plus 4 on the end, and then they start joining terms and they say that this is then a plus 2. Now, the fact that I had 3 things here and I ended up with 3 things here tells me, or 3 things and I was able to simplify, tells me I've done something wrong.
Why did you put -2?
Because the derivative of -2x is -2.
But you wouldn't normally have a plus for that.
What's wrong here?
So you just get rid of the 4?
So what I'm saying to you is that the fact that you, if you wrote this and were like, oh, I'm going to simplify, should ring alarm bells and tell you you've done something wrong. Okay? I'm always trying to help you when you're in an exam situation, but if you end up doing something, I'm trying to spot errors that you might make and trying to help you avoid making them. Okay? So if you end up joining like terms, you've made a mistake, is what I'm saying. Okay? Yes.
If they ask you a question with f1 x, do we have to do it in that form, or can we do dy over dx?
You should be writing the correct format. Whether they deduct marks for writing the wrong thing, I would hope not.
Okay, but they just mean the same thing.
Yeah, the process is the same no matter what. That's why I'm trying to mix it up in my notes. I remember this version had all in white, so I was trying to mix it up. All right, so process so far so good. Yes. Who said no? Oh. This is where it starts to become a bit tricky because you're having to remember your index rules. Okay? So, if it's a negative power, rule still applies. Okay? The power comes in front, and you take 1 off the power. Be careful here. If I multiply by -3, lovely, x, if I take 1 off this, what does it become? -4. So it becomes more negative. So again, the process is not different. You're just having to deal with negatives. But unfortunately, they don't normally write it like this. They are more likely to write your question like this. Okay? And so this is where they're bringing together your remembering your knowledge of index laws. So if we have something written like this, so 1 over x to the power 4, so if it's written as a fraction, you need to write it as a power. Okay, so this is not, I know there is a power in our fraction, but you need to change it. So, my first step is just to write equals, because I have not differentiated it yet. I'm just going to change the format of it. How else can I write 1 over x to the power 4?
X to the power of negative 4.
X to the power of negative 4, perfect. And I will leave it at that because it's the end of this. Okay?
So